Alright guys, welcome back to my YouTube channel. Um Sincerely, it's been a while. It's been a very long time. Um alright, so I am starting a series of videos where I am basically gonna teach you guys how to build AI agents or build apps that are powered by large language models. Now, if you don't know what a large language model is, it's basically something that most of us already interact with every day, right? A good example is ChatGPT 3.5 or ChatGPT 4. Now, ChatGPT 4 is referred to as a large language model, sometimes referred to as LLM. So these are basically AI models that are designed to process. Um, initially, the whole idea was for them to process, tests, right, and predict the next word. So you put in some tests and then the output is tests, right? But nowadays, these large language models are now having something we call multimodality, where they're not just taking tests, right? Some of them can take images, some of them can take video, some of them can take audio, right? However, at the end of the day, the output is usually a text, right? A string, a bunch of written characters, right? So yeah, we can say they are still fair to call them large language model, right? Now, like I said, most of us are already familiar with this AI, and we use it. A very popular example is ChatGPT. So as you can see on my screen right now, I have the 3.5 loaded on my screen, and I can send a message to this system like hi, and then the system is able to predict and give you like the most meaningful response to that message, which in this case is how can I assist you today, right? Now, this is basically what these guys do: taking tests, output tests, right? Meaningful tests, obviously. Now, the tests, the outputs are usually based on the training of these models, right? So they have been trained on a bunch of tests, some of them taken from the internet and some other sources, right? But at the end of the day, the response is basically limited to what data the model has been trained with, right? So if you ask questions that are very, very recent, like who is the president of Nigeria today, right? Let's ask that question. Who is the president of Nigeria today? Now you get the response that says something like, as of my last updates, right? So this was the last time the model was trained. So you're already seeing some limitations to using this LLM, and the limitation is that one of the limitation rather is that it's just limited to the data it has. If I ask this question like who is Daniel, I'm Daniel, right? It's gonna say something like I'm sorry, without context I can answer. Sorry, not so what is Daniel? who is Daniel, right? So probably gonna try and say something like, are you referring to Daniel in the Bible or Daniel blah blah blah? So now the response is Daniel is a common given name used in various cultures around the world without further context. So this is where I'm going to, without further context. Let me zoom this in so you guys can see this clearly. Now take note of this here. Without further context, it's difficult for me to determine which specific Daniel you are referring to. Now I had to show you guys this, right? Because this takes me to my next point, right? Now, one of the most common apps that are being built using LLM, powered by LLM, is something we call Retrieval Augmented Generation, commonly known as R.A.G, Retrieval Augmented Generation. Now, a R.A.G system is basically an LLM that has access to context or has access to a database of different contexts, right? Expanding the knowledge of the LLM. So imagine I take this ChatGPT 5, 3.5, right, and give it context about who Daniel is, and then I ask this question about Daniel, then it's able to answer my question. For instance, I can say, uh, Daniel Daniel is a developer, right? Is 44 years old. Now let's call this, let's say this is the context I am feeding into the system, right? And then I can say question, how long how long has Daniel been on Earth? Now I have a context and I also have a question. Now ChatGPT is able to respond to me and saying Daniel has been on Earth for 44 years. Why? Because now it knows the exact Daniel I'm referring to and it has context about that Daniel. So this is basically what a RAG is, right? It is building AI agents or AI system that are powered by LLM, right? But not just LLM that have access to a database of context. So what happens is that you ask the AI system a question or the AI agent a question, right? It is able to go into the database of context it has, fetch the appropriate context to answer that your question. That's the retrieval aspects, right? And use that retrieved, sometimes it's called documents, retrieved documents to basically gives you the best answer to your question. So retrieval of documents to augment the response of the LLM, right? So this is one of the most interesting things to do with LLM, and we're going to do that. Now I'm going to create different parts for this particular RAG project, right? We're going to take it from, we're going to do something very, very simple, then we'll keep making it more advanced as we move, towards the end of the RAG part of this tutorial. So yeah, I think I have like 5 parts. So 5 RAG system with different complexity, just for us to understand the beauty of LLM and prompt engineering. Alright, so let's just get straight into it. Alright, so I am going to open my IDE here. Alright, so what you're seeing right now is my Visual Studio Code, and all I have done is just to create a interactive notebook file. So I have this file called 1.ipynb. That is how you create an interactive notebook file on so we know what RAG is already, and we know the goal of RAG is to be able to answer questions using LLMs, but answer questions by providing context to the LLM, right? Before we proceed, the first thing we want to do is to set up our Conda environment so we can have the necessary things, right? So somewhere in the description of this video I have the link to the GitHub repo so you can find everything you need, right? But just to make things easier, I'm going to create a file, right, called requirements.txt. So let's start creating a new file here called requirements.txt, and in this file I'm going to put in all the Python package that I think we're going to need for this project, right? Not necessarily in this first part of the project, but in the entirety of this RAG project. We're going to be using something called LangGraph, but not now. That will be towards the end of the project. I'm going to be using something called basically we don't even need most of these things, right? But what we need right now is just LangChain. We need LangChain OpenAI, and we need LangChain experimental. I think these are things we need right now, but I'm just going to keep all the other things here for now, right? So now you want to create a new Conda environment. There are several ways to go about that. This is not a tutorial on how to create Conda environments, right? So I'm just going to select one that's already existing, and so I have a Conda environment that I've created earlier called LLMs. I'm going to just use that, and here we can start. Now before we proceed to building a RAG system or a basic RAG system, let's even figure out how to use ChatGPT within our Python code, right? What I showed you before was just basically using ChatGPT from the provided web interface. Now the first thing you're going to need is to get your OpenAI API key, and you need to set that key here. Now to do this, it's actually very straightforward. You go to the ChatGPT you go to the OpenAI, you create an OpenAI account, and you get the OpenAI API key basically, right? And you set that key here. Now, I already have mine set behind the scene, so I am not going to run this code. Yeah, you have to get yours, right? So that's it. So let's move to the next thing. The next thing is, how do we make requests? So like I said, I'm going to be using LangChain. Now there are other ways, there are other Python package that helps you build LLM apps, right? However, LangChain seems to be the one I'm really comfortable with, and it has a lot of features that I really like, right? Which I will show you guys along in the videos I'll be posting. So, but basically we want to import some things from LangChain. So these are the things we want to import. We want to import chat OpenAI from LangChain OpenAI, and we want to import these messages objects here: AI message, human message, and system message. So when you are dealing with LLMs, especially ChatGPT, there are several kind of messages, right? There's the AI message. This is basically the message coming from the LLM itself, from the model. There's the human message. This is the message you as a human are giving to the model to process. And there's the system message, which is basically the message that you use to control the behavior of the model. So the system message is where you say things like you are a RAG system, or you are a virtual assistant, or you are this and that, just to tune the tone of and the behavior of the system. I'm going to see how to use all this, right? But first of all, we want to import these packages and modules. Now that we have that imported, we can move to the next cell. Now we want to create an instance of the chat OpenAI. So I'm just going to call this LLM, right? And I'm going to say chat OpenAI. Then now you want to specify the model you want to use. Now there are several models. There's a 3.5, there's a ChatGPT 4, but I'm going to be using the GPT-4 preview, right? I'm going to be using this. Yep. Now we have an object that is basically an instance of this class here. And what does this do basically? Now we can now pass in messages to this object and get a response. Now the way you pass in messages is, because this is a chat model, it's a model that is basically designed to handle conversation, right? So your messages are not just one, it's not just a simple in and out, right? You have like a conversation history, right? So we need to create a Python list called messages, right? This will be an empty list for now, but then this list is where we append our messages to before we send to the model. So remember I said there are three basic types of messages. We have the AI message, the human message, and the system message. The AI message is the message coming from the AI. Human is your own message. So what I'm going to do is this. We're going to start by creating a system message, right? So we're going to say system message. Let's do it that way, right? Let's just call it sys underscore msg, right? And this is going to be an instance of the system message that has been imported earlier. Then we're going to add the contents to this. Now remember I said the system message is basically where you control the behavior of the model, right? So I'm going to say that you are a virtual assistant who has the personality of a Nigerian pastor. Now that's going to be the system message, right? Then I'm going to append this message to our list of messages. So dot append system message. Now we are also going to create our human message, right? This is like the input of the chat, right? So let's just call this hum underscore msg, right? And I'm going to create a human message time around with a content that says how how do you feel about AI and the future? Now this is the actual question we want to ask the system, right? And we're also going to append this message, right? So the message, right? So we're going to say messages dot append human message, right? So now we have a list containing a system message and a human message, right? Now let's just for clarification, let's print out these messages and see how it looks like, right? So I'm just going to print this out, and you can see that we have two messages here, system message and the human message. Now let's process this message using the LLM objects we created here. So very simple, just need to say LLM dot invoke, right? Then we're going to pass in messages. Now we're going to save the response coming from this, because this is going to give us a response, right? So let's save it in a variable called res, right? So I run this, takes some few seconds, and we get a response from GPT-4 preview. Now sometimes it takes time because, of course, this is making an API call to the chat GPT API, right? And then sometimes your network might also be a problem. It's not supposed to take this long, basically, but yeah, it happens sometimes. Okay, fine. Now the code has been executed, and let's see what rest looks like. Now if you look at this says this is an AI message. So because that's a message that has been generated by the LLM itself, and the content says, now look at the tone here: my beloved, the future is indeed a place of great mystery, but it's also a canvas for the Almighty to manifest His glory through the works of human hands. AI, like any other creation of mankind, has been bettered through the wisdom that God has generously given unto His children. AI, as I perceive it, is a tool. I don't know what that means. It's a tool that when God, okay, a tool that when used with divine guidance. Oh, now I get it. It is a tool. Okay. Now it's talking like a Nigerian pastor. Now I get it. So it's a tool. Tool that when used with a divine guidance and moral compass, blah 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 blah. Now you guys get the concepts, right? The system message is where I was able to tell the system that, oh, you need to have the personality of a Nigerian pastor, right? And that's why the response is coming out in this, format, basically. Now, res here is not a string. Very, very important. We need to note that. So we have different data types in Python, but res here is not a string. So if you actually print out the type of res, you can see that this is actually an AI message coming from the core messages module of LangChain. And what does this mean? This means that this is basically an instance of a class with different attributes. Now, if you type in res.content, you should get the actual content. String is not callable, blah blah blah. Okay, sorry. Yeah. So res.content will give you a string. So this is actually a string now. So if you want a string response, you have to get that from the content attributes of res, right? So that's very, very important to take note, because this would actually come in handy when we move to other advanced thing. Now, this is how you basically pass messages to ChatGPT via LangChain and then process it. Now, R.A.G. Now let's go ahead and ask another question. Let's ask the question, who is Daniel? Just like we did with the web API. Now, if we print out the contents, process this and print out the contents, and take some few seconds. I think my network is actually really bad right now, but while that is processing, sometimes, because we've asked it to, okay, it's good. So it says the name Daniel can refer to many things, including a biblical figure. Now the point I'm trying to make here is that it is answering the question, who is Daniel, based on general knowledge, right? But actually, let's assume that you are building a chatbot for a company, right? And what the user intends to do is to have information about the CEO of that company, who is Daniel, right? So if I say, who is Daniel, I expect the chatbot to say, oh, Daniel is the CEO of so 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 and so, or Daniel is an AI engineer, blah 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 blah. But in this case, the AI has no idea who Daniel is, right? So now this is where R.A.G comes in. I'm going to give some context, right? And we can then see if the system is going to answer the question. So I'm going to just copy a piece of code I have here, and I'm going to paste that here. So what I've done now is I'm appending a system message that says, you are an helpful AI who is designed to tell you the life story of Daniel and answer questions about him. Now I'm providing a context within the system message here. I'm saying Daniel is an AI and IoT engineer, is 40 years old, and he works for Google. What does Dan do? That's the human message. So if we run this, we expect the AI to now answer the question properly because it has some context here to work with. So let's see what the response look like. So you can see that the response says Daniel is an AI and IoT engineer. He works in Google, where he likely engage in creating, developing and maintaining AI system and IoT. It might involve his work. It might involve blah 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 blah. You should see they answer that question properly, or because we're giving it some context. Now, it might look like this has solved the problem, right? But let's assume we want to scale this up, and we want this chatbot to answer questions about any employee within a company. Now imagine the context for each employee is about 10,000 words. So this context here for Daniel contains like the life history of Daniel, and is about 10,000 words. And now you have to fit that for each employee into the context. So you say Daniel is this, you can say James is so 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 and so, right? Now what will happen is that eventually you're going to have too much information being fed into the system message, right? And this would have so many problems. Number one, it's going to be expensive. Now take notes, whenever you call the ChatGPT endpoint or API to make all these requests, right, or process this input, right, you're actually being debited from your chat OpenAI account. And the way the charges are being determined is based on the number of token. So I don't want to go into what token is, but just the lame way to imagine what token is, just say the number of words in your message, right? Both inputs and outputs, right? So imagine if you have to feed a lot of context just so that the system can answer any kind of question related to the employee in a particular company, right? You're going to be spending so much money every single time you run this code. That's number one problem. Number two problem is that sometimes some contexts are just way beyond the context window of the LLM you are using. So though ChatGPT 4, which is what I'm currently using, has a context window of about 168 or 16 token, right? But imagine you have 20 employees, and these 20 employees all have very very detailed life history or context about their life history, right? By the time you put 2 or 3, you've already filled up the context window of the LLM, right? You're going to have so many issues. And let me show you what that means basically. Now I'm going to just multiply this string by, let's say, 200,000, right? And then try and run this command. So does that work? So I'm trying to multiply this content here by 200,000, sorry. Right, let's run this. Now this is just a lazy way of me trying to, I'm trying to test the limits of the context window, right? And you see I'm going to get a problem here. It's going to take a while to run this, but the problem I'm going to get is that I'm going to get the error that says that we've gone beyond the context window of the LLM because we've sent in too many text data, right? And you cannot process it, which is what is going to happen eventually when you put too much context, right? So aside from spending too much money, there's a very high chance that you hit the limits of the context window of the LLM. That is the reason why you cannot just embed all your context into your question to do a RAG system or into your system message, right? Now, the other third disadvantage of trying to put your context like this manually into the system message is that you're probably wasting money. This is still related to the first point. Now, you might have like 20 employees and you've put in the 20 context to answer the questions about those employees, right? But maybe 90% of the time, the users of your chatbots are only asking information about 5 employees, let's say like the CEOs and the co-founders. Now you have information within your system message that are not being used, and it just makes the whole process or the chatbot slow, right? Because it's trying to find like answers within very large context, right, that not necessarily provide the right answer for that question. So you can see that there's already a big problem with putting your context in your system message like this or in the message generally. So how do we solve this problem? Right, so like I said, I'm going to start with a very simple solution, then we'll advance gradually into the standard of at which this thing is being done. Like you can already see that we're having a problem here. This code has been running for a very long time because too much context. So imagine I'm building a chatbot now. The chatbot is taking me like 2 minutes to respond to me. It doesn't make any sense, right? And that's because we are sending so much data into the system. Alright, so I'm just going to stop this, or while that is running, I'll just leave it running. I'll copy the next piece of code and let's just proceed. Now, one solution, right, is to just manually put in your context as a list of string like this. I'm going to stop this right now. It's already causing too much trouble. Okay, that was a lot of context actually. I'm just going to restart this guy, and I'm going to run this again, and I guess we are good. Then we can move to the next one. Yeah, good. Now look at this code here. I have a Python list that I call context.db, and here we have 3 contexts basically. We have one that says Daniel is 45 years old, so basically this is answering the question, how old is Daniel, right? We have another context that says Daniel works in tech. This is answering the question, what does Daniel do, or what field is Daniel involved in, right? And this is another context that answers the question, still related to job also, right? So we have this Python list here, and we're going to call this list our context DB. That's our context database, right? These are the contexts that the LLM have access to answer any question asked by the user. Now the user question is, how old is Daniel? And we're going to create our messages. We're going to create a system message that says, you're an helpful AI assistant who is designed to tell user the life story of Daniel and answer a question about him. Use the context provided to answer the question. That's all we have in the system message. Now we're going to create an input message, which is basically a Python string. I will say, here is the context. Then we put in a specific context here, and we'll say, and this is the question. Then we put in the user's question here. Hope that makes sense, right? So I'm just going to cut this out and run this for now. Now note that we are using the first context here, which is index 0, which is this context here, right? So now if you actually check what the input message says, it says, here's the context, Daniel is 45 years old, and this is the question, how old is Daniel? Now I want you to take note of this. We are not passing the entire life history or context of Daniel. We're only passing the specific context within this context DB that we think answers the question that the user is asking. So it's more like this is like a manual RAG system. We're looking at the user question. We're saying, okay, this user question, among the contexts that we have in our database, which of these contexts answers the questions? Oh, it's the first one. Let's pass that. Use that to create our final input message for the LLM, right? Then now we can now pass that input message as a human message, right? Append that to our messages, then invoke our LLM with that message, and we can print out this. Now the system should be able to accurately answer the question, Daniel is 45 years old, right? Because we're giving the right context. But this does not make any sense There is no way to magically tell the question that the user will ask, right, and add code the part of your context DB or which context will be used to answer the user's question. I'm only trying to use this just to explain how RAG works in a very simple way, right? Now, the next question you want to ask is, how do we automate this process of the system? How do we create a system that can fetch the right context based on the user question from the context DB and use that to create the final input message for the AI? And that is simply the question that we, that give birth to RAG system. Now, there are so many ways to go about that, right? And there are so many advanced techniques. But like I said, I am trying to build up projects from very, very simple, very, very basic to advanced techniques. So I'm going to try a very simple, logical approach to solving this problem, right? And I'm just going to copy another piece of code here, and I'm going to paste this here. Now, look at this. I've added one more thing here. I have my context DB here. I have a function called context search, and this function takes in the context list, which is basically the context DB, and takes in the user question and does a very simple process here. It's like an algorithm that does check. Now, it checks the word in the question. So if you ask the question, how old is Daniel, right, it checks if any of those words in the question, how old is Daniel, matches any of the word in any of these contexts here, right? So if you ask how old is Daniel, obviously it's going to say that, oh, your question has old and Daniel has, this first context has old, and then it's going to use that context to answer your question, right? So this function just takes in the context list, which is this, takes in your question, do some kind of word matching, right? Find words that matches based on this, right? And then return that context. Now the question is, how long has Daniel spent on Earth? Now, it's definitely not going to answer this question. Why? I'll tell you why. But before we get to that, let's try a question that is going to answer. So I'm going to say, I'm going to say, how many years old is Daniel? Now, the reason why I'm doing this is, for this system to work, you have to have a word that matches the context needed to answer that question, right? So now, just like we did above, I'm creating a system message. I'm doing a context search with this function here, passing the contents DB and user question, right? Hopefully, this context search do a word-to-word match and realize that, oh, this one has years in it, and the question also has years, and I return that context to us, right? Then we have the perfect context. So let's run this. Now, within this function, I'm printing using context, right? So we can see what context is being used. So if I run this, you can see it's saying using Daniel is 45 years old. So it has figured out that, oh, doing a word-to-word match, I can see that this is what matches, right? And I'm going to use that to answer the question. And now GPT is saying, based on the context provided, Daniel is 45 years old. Now, but the problem is this. What if I ask a question like this? How long has Daniel spent on Earth? There is no word here that matches the context here. So the problem is that it's not going to find any word, basically. I'm going to have a problem, right? So if I run this, you can see that it didn't print out using this because it never got to this part of the code because there was no word here. And now the system is saying, without context regarding who Daniel is, including his birth or the blah blah blah, I can answer your question basically. And that's because this is not this is a very poor way to find the right context, because if the user uses the wrong word, then it doesn't work. This is not applicable in the real world. So, as a engineer or a developer whose task is to build a RAG system, the real job, or one of the real tasks you have to face is to find the best algorithm that matches the question to the right context. Because at the end of the day, you cannot fit in all the entire context into the LLM. You have to find at least a chunk or a portion of the entire DB that is most likely, related to the question to answer that. So you will spend most of your time figuring out how to perfect this context search. Now, I think I'm going to stop this video here because it's really, really getting long already. And in the next video, I want to talk about the advanced algorithm you can use to make the system much more better. So no matter how the user asks this question, either he use the word in the context or not, the system is going to be able to fetch the right context. And that's going to be in our next class. Thank you very much, and I'll see you guys in the next video.